Now let us move on to the next question. Here this R is relation and this R is nothing but real numbers. That is, this is set of all real numbers. In this set, relation is defined as A lesser than or equal to B cube. For reflexive check, A should be lesser than or equal to A cube. This is true for whole numbers. For example, 2 is lesser than or equal to 2 cube. That is, to be precise, 2 is lesser than 8. So that's true. However, 0.2 lesser than or equal to 0.2 cube, this is not possible. Thus, R is not reflexive. Let us do symmetric check. If R is symmetric, then A less than or equal to B cube is true and B less than or equal to A cube should be true. This situation is not possible in R, thus R is not symmetric. Of course, this is not for any number, this situation is not possible for many of the numbers. The chosen A comma B is that 1 comma 3, 1 is lesser than or equal to 3 cube, this is true, but 3 lesser than or equal to 1 cube, this is not true. If R is transitive, then A less than or equal to B cube is true, B less than or equal to C cube is true, and we need to prove that A less than or equal to C cube. This situation is not possible for, again, most of the numbers in R. For instance, if I consider A equal to 10 and B equal to 3 and C equal to 2, 10 lesser than or equal to 3 cube, this is true, B lesser than or equal to C cube, so 3 lesser than or equal to 2 cube, this is true, but 10 lesser than or equal to 2 cube is not true. You may argue, what if I take A equal to 1, B equal to 2 and C equal to 3? Then 1 lesser than or equal to 2 cube, this is true, 2 lesser than or equal to 3 cube is true, and 1 lesser than or equal to 3 cube is also true. But why we still say that it is not transitive? Because this relationship has to be true for all numbers in the set of all real numbers, not just one part of the set. So, though this is true for some of the numbers, this is not true for other set of numbers. And that's the reason why we say it is not transitive. Now the next question. Show that the relation R in the set 1, 2, 3 given by 1, 2, 2, 1 is symmetric but not reflexive nor transitive. It is symmetric because we have 1, 2 and 2, 1. It is not reflexive since we don't have 1, 1 or 2, 2 for that matter. And it is not transitive because it doesn't contain any third element such that A comma B, B comma C and C comma A satisfy R. Note the third element need not be a completely different element than first and second. Had there been 1 comma 1, that is, if R is defined as R equal to 1 comma 1, 1 comma 2 and 2 comma 1, this is transitive because I have 1 2 and 2 1. So this is the first element here, second element here. So this is still transitive. However, since we don't have 1 comma 1, this is not transitive. Now moving to the next question. Show that relation R in set A of all books in the library of college given by X and Y have same number of pages. And we need to show that this is an equivalence relation. If R is reflexive, then X comma X belongs to R. That is, X and X have same number of pages, and this is true. If R is symmetric, then X and Y belonging to R is true. We need to check whether Y and X also belong to R. So if X and Y have same number of pages, then definitely Y and X will also have same number of pages, and hence R is symmetric. Now going for transitive check, if it is true that XY belongs to R, YZ belongs to R, then definitely XZ should belong to R. If X and Y has same number of pages and Y and Z have same number of pages, definitely X and Z will also have same number of pages. Thus it is transitive as well, and hence R is an equivalence relation.